Hey, I'm Abraham. I'm the CEO and founder of Sculpt, and today I want to show you very quickly how we can use Sculpt to create our own artificial intelligence model to detect xenophobia on Twitter. And all of that without having to write a single line of code. So, we're going to go from left to right. The first step is to configure our project. We're going to give it a name, we're going to add the data set of raw tweets, and we're going to set up which types the model is going to be distinguishing between. In this case, it's going to be between xenophobic or normal tweets. For each type, we can pick whatever color we like to represent it. After we do that, we can go to the labeling tab, and here our job is to give 50 examples of each type to the model. And that way, those examples are going to be used later on to evaluate the model and make sure that it's performing correctly. So for example, here we're just going to label, boom, boom, boom. To the left, we can see the current count of examples we have for each type. And when we get to 50 of each type, we can go to the next step, which is the annotation step. This is one of the most important steps, because this is where we actually infuse our knowledge into the model. So there are two ways to do it. The first way is with active learning, which is a way to pick an example that will give the most information to the model. And that way, it will make this process much more efficient. So with active learning, when we get an example, we look at the example and then we highlight the phrases in the example that give us the most evidence that this example is xenophobic, for example, or in the other, for example, xenophobic. Or we can also highlight a part and say that it's normal. Then the other way to do it is through search. Basically, sometimes we already know some words or phrases that have a lot of signal and that are going to find a lot of xenophobic tweets in this case. So for example, let's look for "send her back," which is what people were chanting at Trump's rally last week, right? So maybe this is going to find a lot of xenophobic tweets, also some normal tweets. You can also highlight here. And the important thing of this search feature is that it's giving you the option to even infuse more knowledge into the model, because you are choosing which examples you're labeling. And that's basically giving a lot more information to the model about what to look for. Then the other important thing of this page is here to the left is the progress graph. This graph gives you real-time feedback on how accurate your model is at a given time. So that way, when you achieve the accuracy that you want, you can stop and go to the next step. And all of these things, the active learning, the search, and the real-time feedback, go back to our philosophy of being very efficient. We want this to be the most efficient process possible for you to build the models that you need. So, when we're done here and you're happy with your accuracy, you go to the next step, which is the rules tab. In the rules page, you can visualize what your model is doing, what it's looking at. Basically, it lists the criteria that the model uses to make decisions. So let's look at an example here. Let's go to the rules for xenophobic tweets. Here we can see the rules that basically we can see that if the tweet says illegal and alien, there's a very high chance that the model is going to classify the tweet as xenophobic. We can also go down, we see, oh, okay, if it says send them all, then it's probably going to be xenophobic. And the interesting thing of this is that we can basically visualize the model's criteria and understand what it's doing. On top of that, you can also edit the rules, delete rules, or add your own new rules. So this kind of goes back to our second kind of technical philosophy and user-focused philosophy, that the models must be humanly understandable. Because as you can see, these rules are not just like numbers, statistical numbers. These are things that anyone can understand and manipulate. So this is humanly understandable and also debuggable and manipulable. Like you can edit the rules, edit, delete, and add new rules. So that goes to kind of our second pillar. And finally, when you're happy with the rules that the model is using, you go to the evaluation page. And this is going to use the model on random examples and show you the results so that you can see if the results actually make sense before you start using the model. So for example, here you can look at tweets that were predicted to be normal, or you can also look at tweets that were predicted to be xenophobic. Look at it, and then you can look at a bunch of examples, and if it looks good to you, you're happy, then you just click the button deploy, and it's basically going to put the model on the cloud and start running it and open up an API that anyone in your organization can use, like any developer in your organization can use to integrate the model into your own workflow. So as we can see, Sculpt is very efficient, it's explainable, and it's debuggable. And finally, we can see that it's very easy to integrate into your workflow, even though we still have more work to do on that front, because we want it to be as easy as possible to integrate without even needing any type of developer to use the API. So thank you very much. And also, by the way, full disclosure, we actually open sourced a xenophobia detection model for Twitter a week ago. Basically, the model that we open sourced a week ago was made through this process, and we haven't told anyone before. So if you're interested in reading the blog that we put out last week, please just go to the link below. It's gonna be at the Medium blog, and yeah, hope you enjoy that. Thank you.